Imagine a colossal steel fortress weighing 100,000 tons, slowly rising from a dry dock after being flooded with 100 million gallons of water. This is the birth of a Ford-class aircraft carrier, the ultimate symbol of American naval engineering. From meticulous construction in Newport News to the innovative technology of the electromagnetic aircraft launch system, these floating giants represent not only military power, but also the U.S. commitment to global freedom. Discover the story behind the creation, launch, and future of these impressive machines that project strength, ensure national security, and influence the global geopolitical balance. But before we start, make sure to subscribe to our channel and leave your like. Now, let's get started. Theme 1: The construction and birth of the USS John F. Kennedy. A colossal steel fortress weighing an astounding 100,000 tons lies silent and immobile within a concrete canyon surrounded by towering walls. Suddenly, with the press of a single button, 100 million gallons of water surge into this cavernous dry dock like a controlled tsunami. Within hours, this gargantuan warship, longer than 3 football fields, lifts from its concrete cradle and floats for the very first time. This is not science fiction, it is the breathtaking reality of how America's most powerful naval weapons come to life. In October 2019, the USS John F. Kennedy, the United States' second Ford-class supercarrier, experienced this precise moment. After 4 grueling years of meticulous construction, this guardian of freedom, valued at $13 billion, finally met the water. But the journey from raw steel to floating city is far more intricate and awe-inspiring than most can imagine. Today, we invite you inside the extraordinary engineering marvel behind launching an aircraft carrier. From the immense dry docks of Newport News to the revolutionary electromagnetic catapult systems that launch fighter jets into the sky, you will discover why America's carrier fleet remains the most respected and feared naval force on the planet. If you feel pride in the Navy's incredible achievements, type pride in the comments below. The Cradle of Giants, nestled on the banks of the James River in Virginia, lies Newport News Shipbuilding, a historic complex where America's floating fortresses have been forged for over a century. This shipyard isn't just another dock, it is the only facility in the United States capable of constructing nuclear-powered aircraft carriers. At the heart of this operation are immense concrete dry docks, engineering marvels in their own right. Dry Dock 12, the birthplace of the USS John F. Kennedy, measures over 600 meters, nearly 2,000 feet in length, and 75 meters, around 250 feet, wide. To put it in perspective, nearly 500 school buses could line up side by side within this space. Yet what truly sets aircraft carriers apart is how they are built. Unlike most ships, which are assembled in sections, carriers are constructed from the keel up as a single continuous structure. Every pipe, every cable, every room is meticulously planned and installed as the ship rests on giant concrete supports known as keel blocks. These keel blocks are engineering masterpieces themselves. Crafted from reinforced concrete with wooden tops to cradle the steel hull, they bear the colossal weight of the ship throughout its construction. The USS John F. Kennedy, tipping the scales at roughly 800 fully loaded Boeing 747s, rested on these blocks for 4 years. During this time, thousands of skilled workers, from steelworkers shaping the hull to electronics experts installing cutting-edge radar and communication systems, collaborated to breathe life into the vessel. In total, more than 3,200 shipbuilders and 2,000 suppliers from across the country contributed their expertise, embodying the very best of American craftsmanship and ingenuity. Theme 2: The controlled flooding process and the moment of floating. The controlled flooding, engineering precision meets titanic scale. On October 29, 2019, Newport News Shipbuilding became the stage for a monumental event that encapsulates both cutting-edge engineering and the sheer power of human perseverance. The USS John F. Kennedy, a leviathan of steel weighing over 100,000 tons, prepared to take its first embrace of water after 4 painstaking years of assembly. This process, known as controlled flooding of the dry dock, is a precise ballet of hydraulics, engineering, and timing. Dry Dock 12, the gigantic basin in which the carrier rests, slowly fills with water pumped from the nearby James River. But this isn't just a simple filling of a swimming pool. The operation involves carefully calibrated increments to avoid damaging the fragile new vessel or overwhelming the infrastructure supporting it. At the core of the operation is the keel block system. These concrete and timber platforms have supported the ship since its very inception, bearing its colossal weight while allowing workers to construct every every element from below and around the hull. As the dock fills, water gradually submerges these blocks, transferring the weight from the static concrete to the buoyant force of the water itself. Engineers continuously monitor this transition. Sensors placed beneath the hull measure pressure changes in real time. Hydraulics experts calculate the water's flow rate, ensuring that currents do not cause undue stress on the hull or the dock walls. Even the smallest miscalculation could lead to structural damage or costly delays. In the early stages of flooding, the water reaches approximately 3 meters, partially submerging the keel blocks. This phase is critical. At this point, the ship is still resting on the blocks, but the water's buoyancy begins to reduce the pressure on them. Engineers pause to check for any unexpected movement or shifts in the hull. When all readings are stable and satisfactory, flooding resumes. Gradually, over hours, the water level rises, enveloping the entire hull. The transition is almost imperceptible to the untrained eye, but monumental in engineering significance. The ship shifts from a massive weight bearing on solid concrete to a vessel buoyed by water, ready to float. The moment of truth, when steel meets water. For the thousands of workers who contributed to the Kennedy's construction, this moment is filled with emotion and pride. Mike Butler, the Kennedy program director, reflected on the day. The flooding of the dry dock is a historic event in the ship's construction, and a special moment for the men and women who worked to bring the ship to this point. The floating of the USS John F. Kennedy represents more than a technical milestone. It symbolizes the culmination of years of collaboration among shipbuilders, engineers, designers, and suppliers nationwide. When the dock reaches full capacity, holding over 380 million liters, approximately 100 million gallons of water, the carrier no longer rests on the keel blocks but floats freely, a testament to the power of displacement and naval architecture. The ship gently rises, supported by water's buoyant force, its massive steel hull lifting as if awakening from a long slumber. In practical terms, this is the first time the vessel will experience the conditions of buoyancy that it will face in open seas. It is the critical step before the ship's transition from a construction project to a living, breathing warship, a historic milestone ahead of schedule. Remarkably, the Kennedy reached this milestone 3 months earlier than originally planned, a feat that underscores the commitment and skill of Newport News Shipbuilding's workforce. This achievement was made possible through advanced project management techniques, the adoption of modular construction methods, and an intense focus on quality control. Modular construction involves building large sections of the ship separately and then assembling them in place, a method that accelerates progress and allows different teams to work simultaneously. Even with this complexity, the coordination needed to ensure each module fits perfectly upon assembly cannot be overstated. This early flooding also allowed the shipyard additional time for outfitting the carrier with the latest systems, including state-of-the-art radar, communications, and electromagnetic aircraft launch systems, emails, that are revolutionizing naval aviation. What happens after flooding? Once afloat, the USS John F. Kennedy undergoes a careful repositioning within Dry Dock 12. Tugboats and specialized dock equipment slowly guide the carrier toward the western end of the dock, where she will undergo rigorous testing and inspections. These tests are designed to validate the ship's watertight integrity, stability, and readiness for further outfitting. Engineers check every hull seam and weld for potential leaks, while technicians evaluate ballast tanks to ensure precise weight distribution. The carrier will also undergo harbor acceptance trials, a series of inspections and system tests while still moored at the shipyard. These trials verify propulsion systems, electrical grids, and combat systems, all critical for the ship's future operational success. Following these tests, the Kennedy will be moved to the outfitting basin, where final construction tasks, like installation of weapons, sensors, and crew accommodations, take place. This stage can last many months, involving thousands more work hours before the ship is ready for sea trials and eventual commissioning. The people behind the giant. While the USS John F. Kennedy is a triumph of steel and technology, it is also a testament to the people behind the scenes. The 3,200 shipbuilders and 2,000 suppliers who contributed represent a cross-section of American industry. Welders, electricians, pipe fitters, engineers, and planners, many of whom have spent their entire careers contributing to the U.S. Navy's fleet. Stories abound of workers who remember their roles in building previous carriers and take immense pride in passing the torch to a new generation. Their dedication is woven into every rivet and cable, forming the backbone of American naval power, a floating symbol of freedom. As the USS John F. Kennedy gently floated for the first time, it marked not only an engineering milestone, but a symbol of American resolve and innovation. This floating fortress, equipped with the latest technologies and powered by a nuclear reactor, stands ready to project power and defend freedom across the globe. Its birth in the concrete cradle of Newport News shipbuilding reminds us that behind every military asset lies a story of human perseverance, ingenuity, and national pride. Theme 3, from floating to testing and revolutionary systems. Post-floating maneuvering and testing. After the USS John F. Kennedy floated freely for the first time, a critical phase began that determines the carrier's readiness for open sea challenges. The ship is carefully moved within the dry dock using hydraulic systems and specialized tugboats to the west end, where a series of rigorous tests is conducted. These tests include detailed checks of propulsion systems, stabilization, and all electronic equipment that ensures the ship's safety and effectiveness. The complexity of these machines is such that any failure can compromise weeks of work and millions of dollars. Therefore, precision is an absolute priority. During this period, engineers and technicians monitor real-time data to evaluate system performance. Sensors distributed throughout the ship collect information that helps fine-tune every component, from advanced radar to aircraft launch and recovery mechanisms. Revolutionary electromagnetic systems. One of the most fascinating aspects of the Ford class, to which the Kennedy belongs, is its revolutionary aircraft launch system. Instead of the old steam catapults, this carrier uses an advanced electromagnetic catapult called EMALS, Electromagnetic Aircraft Launch System. EMALS represents a true revolution in naval engineering, providing smoother and more controlled launches for jets, reducing aircraft wear and extending their lifespan. Additionally, the system can launch aircraft of various weights, from lightweight drones to the heaviest fighters, with greater efficiency and safety. The system consists of a complex set of magnets and electric motors that accelerate aircraft along the launch track, replacing the old cables and steam pistons. This technology marks the future of naval operations and the U.S. commitment to innovation. Offensive and defensive capabilities. The USS John F. Kennedy is not just a platform for planes, it is a true floating arsenal. With the capacity to carry more than 75 aircraft, the carrier serves as a mobile command center and a fortress of defense. Equipped with advanced radar systems, surface-to-air missiles, and anti-air defenses, the Kennedy can detect and neutralize threats before they even approach. Its nuclear propulsion allows it to sail for years without refueling, offering an unmatched strategic advantage. The integration of cutting-edge technologies makes the Kennedy a key piece in the U.S. global power projection, capable of responding quickly to crises and ensuring maritime security anywhere in the world. Theme 4, the legacy and future of American naval engineering. The strategic importance of the aircraft carrier, power projection, and global influence. The launch of the USS John F. Kennedy represents not only a monumental engineering achievement, but also the enduring symbol of American naval supremacy and strategic influence. Aircraft carriers have long been the crown jewels of the U.S. Navy floating air bases that allow the United States to rapidly project power anywhere in the world's oceans without relying on foreign bases. In the modern geopolitical landscape, where maritime control is crucial for trade, security, and diplomacy, these colossal vessels function as versatile tools of national policy. Whether responding to humanitarian crises, deterring aggression, or supporting allies in volatile regions, carriers like the Kennedy are uniquely capable of delivering rapid, flexible responses with immense operational reach. The Kennedy's ability to launch and recover fighter jets via its revolutionary electromagnetic catapults, EMALS, extends the reach of the U.S. military air power beyond the horizon. This capability ensures American influence can be felt in even the most remote corners of the globe, reinforcing peace through strength, economic and social impact more than just a warship. The construction of the Kennedy was far more than a military project. It was a catalyst for economic growth and community development. At its peak, over 3,200 shipbuilders and 2,000 suppliers contributed to the vessel's creation, representing thousands of high-skilled jobs across multiple states. Shipbuilding centers like Newport News not only provide employment, but also nurture specialized skills in welding, electrical engineering, advanced metallurgy, and systems integration. These are professions that fuel innovation far beyond beyond military applications, spilling over into civilian industries such as aerospace, energy, and infrastructure. The extensive supply chain engaged in the Kennedy's production included steel manufacturers, electronics firms, robotics developers, and logistics companies. Defense contracts like these inject billions into the economy, sustaining both local communities and national technological leadership. Moreover, the social impact extends to education and workforce development programs. Apprenticeships, internships, and partnerships with technical schools ensure a continuous pipeline of skilled workers, helping maintain America's competitive edge in heavy industry and advanced manufacturing. The future of naval engineering, innovation on the horizon. The Ford-class carriers, including the USS John F. Kennedy, herald a new era in naval technology, blending traditional shipbuilding excellence with cutting-edge innovation. The Ford-class introduces many firsts: the emails launch system, advanced radar and sensor suites, and enhanced nuclear propulsion designed for greater efficiency and longevity. Looking forward, the Navy envisions integrating even more revolutionary technologies to maintain its dominance. Artificial intelligence, AI. AI-powered systems promise to automate ship operations, enhance threat detection, and optimize resource management. AI algorithms can predict maintenance needs, thereby reducing downtime and increasing operational readiness. Autonomous systems, unmanned aerial vehicles, UAVs, and underwater drones are becoming integral parts of naval warfare, extending the carrier's surveillance and combat capabilities while minimizing risk to personnel. Renewable energy and green technologies. With growing emphasis on sustainability, future carriers may incorporate hybrid propulsion systems and renewable energy solutions to reduce environmental impact and fuel dependency, aligning military strength with ecological responsibility. Cybersecurity. As naval vessels become increasingly networked and reliant on digital systems, protecting these assets from cyber threats will be paramount. The integration of resilient cybersecurity measures will be a cornerstone of future carrier design. Challenges and opportunities. Building giants in the 21st century. Despite the advances, constructing and maintaining such massive and complex vessels remains a colossal challenge. The Kennedy's 4-year build time required impeccable coordination among thousands of workers and suppliers, strict quality controls, and adaptation to evolving technologies. As material science progresses, future carriers might leverage lighter, stronger composites to reduce weight and enhance survivability. Modular construction techniques, refined through experience, will continue to accelerate production schedules while maintaining precision. The knowledge gained from the Ford class will inform not only naval architecture, but broader industrial processes influencing shipbuilding worldwide. Conclusion: a legacy of strength and innovation. The USS John F. Kennedy embodies the proud legacy of American naval engineering, a testament to ingenuity, industrial might, and strategic foresight. As the ship joins the fleet, it carries with it not only the hopes of sailors and citizens, but also the promise of a secure and technologically advanced future. America's aircraft carriers are more than steel and machinery. They are symbols of freedom, deterrence, and global partnership. The Kennedy's journey from a dry dock in Virginia to the vast oceans ahead marks a new chapter in maritime history, one defined by relentless innovation and enduring commitment to peace through strength. Theme 5: Precision Maneuvering, Christening Ceremony, Initial Journey, and Revolutionary Technology on the USS John F. Kennedy. The colossal movement of the USS John F. Kennedy demands extraordinary precision. To transport this floating giant, powerful tugboats, advanced positioning systems, and experienced pilots work in perfect synchrony to guide the ship with millimeter accuracy. We are talking about a vessel whose value exceeds the gross domestic product of some small countries. Therefore, there is no room for errors. Any failure could cause catastrophic damage, costly delays, and jeopardize a monumental project. On December 7, 2019, a date loaded with deep historical and symbolic meaning for the United States, the anniversary of Pearl Harbor, Caroline Kennedy, a direct descendant of the honored president, performed the ancient ritual of the ship's christening. Breaking a champagne bottle against the bow of the USS John F. Kennedy, she repeated the exact act performed 52 years earlier when the first ship bearing this name was launched. This gesture strengthens the link between generations, uniting tradition and history with the construction and operation of these war machines. After the christening, the ship leaves the dry dock and enters the James River, beginning the long journey to become an operational guardian of American interests worldwide. Still far from combat readiness, the Kennedy undergoes a rigorous process of final finishing, additional equipment installation, exhaustive testing, and intense crew training, which must master every detail of the vessel to operate it safely and effectively. Unlike commercial ships often rush to market, military carriers face strict protocols ensuring their full readiness for complex and risky missions. The movement from dry dock to river symbolizes the transformation from a static construction project to a dynamic naval system ready to project American military power globally. The technological highlight of the Ford class is the revolutionary electromagnetic aircraft launch system, EMALS, Electromagnetic Aircraft Launch System. Replacing steam catapults, EMALS offers smooth acceleration, reducing wear on aircraft and strain on pilots, and is capable of launching aircraft of various weights with greater precision. This increases operation frequency, boosting the carrier's offensive capability. Ford-class carriers perform 25% more launches with 25% fewer crew members than the Nimitz class, improving efficiency and cost savings. Despite initial challenges and reliability issues in testing, the Navy continues refining EMALS to meet rigorous standards, demonstrating commitment to excellence and safety. Behind the technology is the human element. Over 3,200 shipbuilders, supported by 2,000 suppliers, dedicate themselves meticulously to every weld and test, ensuring quality vital for crew lives and national security. Theme 6, Construction Challenges, Commitment to Quality, and Global Impact of Ford-class Aircraft Carriers. Although the USS John F. Kennedy has experienced delays, now scheduled for delivery in March 2027 instead of 2025, these setbacks reflect the Navy's unwavering commitment to excellence rather than serious construction problems. Factors such as project complexity, skilled labor shortages, and incorporation of lessons learned from the USS Gerald R. Ford contribute to extended timelines. The Navy prioritizes quality over speed, implementing continuous improvements even if it means delays, ensuring each new carrier surpasses its predecessor in performance and reliability. Workers' pride is evident. They know they're not just assembling ships, but creating platforms that will protect global freedom. These floating cities project military power, provide security to allies, and serve as effective deterrents. For example, after the Hamas attack on Israel, the USS Gerald R. Ford Strike Group was rapidly deployed to the Eastern Mediterranean, demonstrating the strategic readiness and impact of these vessels. A Ford-class carrier carries more firepower than many national air forces, capable of operating up to 90 aircraft, including advanced stealth fighters like the F-35C. Each carrier is supported by a strike group of cruisers, destroyers, and submarines, forming a formidable military force few nations can match. Beyond military impact, the program sustains hundreds of thousands of jobs, from steel mills to high-tech companies, strengthening the U.S. industrial base and sovereignty. Theme 7, International Recognition, the Future of the U.S. Navy. In conclusion on the Ford-class carrier construction, and international partners recognize the unparalleled capability of American carriers. The French Navy, for example, has contracted electromagnetic launch systems, EMALS, and advanced recovery equipment for its next-generation carriers, acknowledging American technological superiority in this critical area. The current U.S. Navy plan envisions maintaining a fleet of 11 carriers, ensuring multiple vessels are available for deployment while others undergo maintenance or training. This continuous presence around the globe provides the flexibility needed to respond quickly to crises anywhere. Although some critics question the high cost, it's important to consider alternatives. Without carrier-based power projection, the US would rely on massive overseas bases, huge transport aircraft fleets, and advanced ground forces, resulting in even higher logistical and operational costs. Carriers offer unmatched flexibility and capability. The future of American naval power is tied to the Ford-class program. With 10 carriers planned through the 2050s and beyond, the USS Enterprise, CVN-80, and USS Doris Miller, CVN-81, are already under construction, incorporating lessons learned and improved construction techniques, technologies, and processes, ensuring continuous fleet evolution. Perhaps the most significant feature is their growth potential. Currently, only half the electrical generation capacity is used, leaving room for future technologies such as directed energy weapons, advanced radar, or yet to be invented systems. Naming CVN-81 USS Doris Miller carries special meaning. Miller, an African-American sailor who heroically operated anti-aircraft guns during Pearl Harbor, symbolizes courage and diversity, strengthening the U.S. Armed Forces. This will be the first carrier named for an enlisted African-American sailor. Future carriers CVN-82 and CVN-83 will honor Presidents Bill Clinton and George W. Bush, continuing the tradition of naming these magnificent vessels after American leaders who understood naval power's importance. Improvements in supply chains and concurrent construction of two ships have already generated significant cost savings without compromising quality, demonstrating the program's growing efficiency. In conclusion, from the moment 100 million gallons of water flood the dry dock to the day these floating fortresses launch into the sea, the construction and commissioning process represents the best of American ingenuity, craftsmanship, and commitment to freedom. These vessels carry more than aircraft and weaponry. They carry the hopes and prayers of a grateful nation. Every time one of these magnificent ships slides into the water, it sends a clear message to the world. America remains committed to defending freedom and supporting its allies wherever they may be. The men and women who build, launch, and operate these carriers deserve our deepest respect and gratitude. Their dedication ensures the U.S. Navy continues to be the most capable and respected naval force on the planet. Theme 8, Challenges, Dedication, and the Essential Role of Workers in the Construction of Ford-class Aircraft Carriers. Despite the challenges faced during the construction of the USS John F. Kennedy, now expected to be delivered in March 2027 instead of the initial 2025 date, these delays largely reflect the U.S. Navy's commitment to excellence rather than serious structural problems. Often, these postponements result from supply chain difficulties, shortages of skilled labor, and the complexity of incorporating lessons learned from the experience with the first Ford-class carrier, the USS Gerald R. Ford. Each of these factors contributes to extended schedules but also demonstrates the Navy's refusal to compromise the quality of the final product. This dedication is evident in every detail of the construction process. When workers identified ways to improve the Kennedy's build by incorporating enhancements derived from the Gerald R. Ford experience, they did not hesitate to implement changes, even if it meant longer deadlines. This commitment to continuous improvement ensures that each new carrier surpasses its predecessor, becoming more efficient, technologically advanced, and robust. The workers involved are not simply assembling ships, they are creating platforms that will carry our brave sailors and aviators into battle, defending American freedom and interests worldwide. This is a job demanding immense pride and responsibility. The magnitude of this commitment goes far beyond mere engineering or manufacturing. It is a national mission involving thousands of people, from engineers and welders to technicians and electronic systems specialists. The global impact of these vessels is profound. The moment a carrier slides into the water, it begins to alter the strategic calculations of military powers worldwide. These true floating cities not only project American power, but also serve as a deterrent and reassurance for allies, while discouraging potential adversaries from any aggression attempts. The readiness and rapid response capability of these forces are evident in crisis moments. For example, following the Hamas attack on Israel, the USS Gerald R. Ford Strike Group was deployed within hours to the Eastern Mediterranean, demonstrating the quick mobilization capability only a robust naval infrastructure investment can provide. Beyond military strength, the carrier construction program has a significant economic impact exceeding the armed forces' scope. It sustains hundreds of thousands of jobs nationwide, from steel mills producing raw steel to high-tech companies manufacturing the most sophisticated electronic systems. This production chain strengthens the entire American industrial base, generating employment, innovation, and keeping the country at the forefront of naval technology. The importance of this supply chain is internationally recognized. Allied countries such as France have invested in adopting American technologies like the electromagnetic launch system EMALS for their own carriers, reinforcing the recognition of American technological superiority in this strategic area. This also strengthens alliances and creates common interoperability standards among allied naval forces. In summary, the construction and launching of Ford-class carriers symbolize the perfect combination of cutting-edge technology, craftsmanship, and a long-term strategic vision for national security. They reflect the American spirit, innovative, dedicated, and committed to defending freedom and the values that sustain the nation. The story of these steel giants does not end at the shipyard, but extends through decades of service, ready to protect and ensure peace in a frequently turbulent world. Theme 9, the future of aircraft carriers and maintaining American naval superiority. The future of American shipbuilding is closely tied to the continued success of the Ford-class carriers, representing the United States' long-term commitment to maintaining naval supremacy in the 21st century and beyond. Currently, the Navy plans to build a total of 10 carriers of this class, a program extending well into the 2050s, consolidating decades of technological investment, innovation, and industrial capability. Two of these new vessels, the USS Enterprise, CVN-80, and USS Doris Miller, CVN-81, are already under construction. Both incorporate lessons learned from their predecessors, the USS Gerald R. Ford and USS John F. Kennedy, ensuring that improvements in construction techniques, technological upgrades, and refined processes are applied continuously. One of the most notable aspects of these new ships is their planned capacity for future growth and technological adaptation. Currently, only half of the total electrical generation capacity of the carriers is utilized, leaving ample room for integrating emerging technologies such as directed energy weapons, advanced radar systems, or other innovations yet to be developed. The name USS Doris Miller carries deep historical and symbolic meaning. Miller was an African-American sailor who heroically distinguished himself during the Pearl Harbor attack by operating anti-aircraft guns against Japanese invaders. Naming this vessel after him represents the diversity, courage, and determination that strengthened the American Armed Forces. This will be the first carrier named in honor of an enlisted sailor and the first to honor an African American, marking a significant advancement in representation and recognition within the Navy. Furthermore, the names of future carriers CVN-82 and CVN-83 were recently announced to honor former Presidents Bill Clinton and George W. Bush, respectively, continuing the tradition of naming these grand vessels after American leaders who understood the importance of a strong and capable naval force. This practice reinforces the symbolic role of aircraft carriers as national icons carrying the nation's heritage and values. The U.S. Navy has also adopted strategies to optimize construction costs and timelines. The implementation of a simultaneous acquisition plan for the Enterprise and Doris Miller has already generated significant savings without compromising rigorous quality standards. Continuous learning and improvement of construction processes allow reduced time and costs in building these complex ships, ensuring the fleet remains modern and operationally effective. The Ford-class carrier program is a true celebration of ingenuity, craftsmanship, and the commitment to freedom that defines the American spirit. From the moment 100 million gallons of water flood the dry dock to the day these floating giants set sail on their global mission, every step reveals the tireless dedication of thousands of men and women working behind the scenes to keep the United States safe. These ships carry not only aircraft and weaponry, but also the hopes and prayers of an entire nation. Every time one of these magnificent carriers slides into the ocean, it sends a clear and unmistakable message. The United States remains firmly committed to defending freedom and supporting its allies wherever they are. The professionals who build, launch, and operate these ships deserve our deepest respect and gratitude, for their effort ensures that the American naval forces remain the most capable, respected, and feared in the world. Thank you very much for watching the video. If you enjoyed our content, please subscribe to our channel and leave your like. Also, check out other interesting videos appearing on your screen right now, and I'll see you in the next video. See you next time.